Hello everyone, my name is Avkash, and in this three-part video, I'm going to share with you the JoJo GAN, the one-shot face stylization AI machine learning model. If you would ask me why JoJo GAN face stylization AI model, I will give you four prominent reasons why you should care about it. First, you just need one single image to extract the style and need just 30 seconds or even less time along with GPU to complete the training. The second reason is important because the JoJo GAN face stylization is focusing a lot more on the face artifacts or the face landmarks which not all other the face stylization AI model covers, such as the size of eyes or the size or the color of eyes. Besides that, the facial line which has darkness or the width. So with the JoJo face stylization AI model, you will find the model is able to extract these facial landmark features which are very important for the human eye to decipher or to understand, is done very nicely with this AI model. The third big reason is that not only with the human faces, you can also use the animal face to apply these styles. That's another big reason you could say. And in the fourth and the last reason, I would suggest you why JoJo GAN could be a very good choice for you. Because with JoJo GAN, you can control the aspect of his style at two phases. First, you can control the style you are going to extract from your source or the style image. And second, you can also control that what aspect of your style will going to be applied to your target image. So you have a very good control over that. So based on these four reasons, we can say that JoJo GAN could be the very good choice for your face stylization AI model. The JoJo GAN one-shot face stylization library is implemented in this GitHub repo. You can learn more about the research paper and its inner working from this archive article. The pre-designed model related to JoJo GANs are already available at this Hugging Face repo, where you could select a particular model such as Disney and see the results for this, this. There is a Colab notebook also available which you could try in the Google. However, in this video, we are going to cover the same exercise in a very different way so that you could understand all these steps in details and how everything works related to face style transfer from one image to your target image. All the code which we are going to use in this video will be available at my public GitHub repo, and you will learn that at the last of this video. This video tutorial is divided into three different parts. In this very first part of video tutorial, we are going to just learn the full code walkthrough to learn how the inference work using the pre-existing JoJo style model, and we will also build our own style transfer model by using single image, by using multiple image, as well as using a complex style such as animal image. All of this exercise is going to be done at Google Colab, and the result Jupyter notebook you can get from my own ProdRamp GitHub repo. In the second part of the video, we are going to cover the code explanation by using theory. We are going to cover the StyleGAN, how it works, how JoJo GAN uses StyleGAN to build its own style model, and wherever applicable in the Google Colab notebook, we are going to learn the code through various theoretical explanations. So second part is all about theory embedded into the code and explained as your code is being executed. The part 3 of This series is going to cover the model deployment. How you could deploy the JoJo style model to Hugging Face repo. You can create your own account and you can export the models from the training environment and you can deploy over there. We are also going to use the Python Gradio based application to deploy the model. So the third part is all about deployment your style transfer model. So let's get started with the very first part of our JoJoGAN Face Style Transfer AI model. Before we start the Jupyter notebook, make sure you have access to GPU. In the next step, we are going to clone the JoJoGAN GitHub repo to the Google Colab environment, and we will also install the Ninja Linux tools. The JoJoGAN repo is going to be created within this content folder. That's where the JoJoGAN repo is. After that, we are going to import the required packages such as Torch, Torch Vision, NumPy, etc., which are required for us to run this Jupyter notebook successfully. Because we are using the PyTorch, this implementation is in PyTorch, so we are making sure that we are using the CUDA neural network benchmarks. That's why we are setting this true. In the next step, because we have imported JoJoGAN repo, so we are importing certain methods from JoJoGAN repo. So this is where we are loading the modules. So E4E projections is here and util is here. And model directory will be created just little later where all the models will be downloaded. We are also going to import the deep copy from the Python copy module. Now we are creating the style images aligned, models and inversion codes folder. These folders will be created within the JoJoGAN. So you see here the inversion codes folder is added, models is added, and these two were already here. In case if you do not have, then these folders will be created. At this point, I will just close it, and in the next step, we are going to download this library Shape Predictor 68 Face Landmarks from the dlibnet, and we will copy this file from the place where it's downloaded to the models folder. You can validate it. Now we could say that this module is available in our Colab environment. That's here. Next, here are a list of pre-built models, checkpoint, and their Google Drive ID. So based on particular model which we want to use in this Jupyter notebook, we could just call a particular name, and that particular model checkpoint will be downloaded from the Google Drive to our local environment. And much of these checkpoints are also being used in this JoJoGAN sample, which is created at the Hugging Face website. The next, I have separated the Google Colab dependent code versus the code which can be used without Google Colab, because we are downloading a bunch of models to be used with this Jupyter notebook. So this code has dependency on using the Google Drive authentication as to download the models and put them into the Google Drive as well. However, if you would want to use this Jupyter notebook outside Google Colab, then this code may not work. So the original Jupyter notebook from the JoJoGAN creator has dependency on that. So in this exercise, I have removed that dependency. So code from here is dependent on Google Colab. So I will not run this code. Instead, I will be using the non-Google Colab dependent code. So here is the downloader class, which has the download file. And then when you pass which model you want to download, that model will be downloaded. Here, we are creating the object and downloading the StyleGAN FFHQ model checkpoint plus E4E FFHQ encoder checkpoint. So these two models are really very large. One is StyleGAN 2, FFHQ is about 380 meg, and next one is JoJoGAN E4E, FFHQ is about 1.2 gig. So after these two models are downloaded, we can validate that all three models. First the Dall-e library, and then these two model checkpoints are already available in our models folder. If you have CUDA enabled and CUDA is accessible to this device, we could use the CUDA. We can also look into here to see that we do have the GPU available, and because we are using the free version of Colab, so the availability of CUDA will be quite random. We are setting up CUDA. Next, we are going to create the generator. Remember, we are using StyleGAN, which is a composition of generator and the discriminator. So here we are using the generator, and we are using the StyleGAN to FFHQ checkpoint to be loaded as the base model, and then we are going to apply the style as needed. So here we are creating the generator. At this point, our generator is ready, and as you see here that we are using the deep copy, it means the original generator, which has all those dependent objects such as this particular model and any other class associated with this model checkpoint, they all available to this generator object. Now at this point, we are going to set up the source image, and in order to use the source image, the best option for you is to go into this test input and upload your source image. The avkash.jpg source image is uploaded here. That's what referenced here. So we are going to set the avkash.jpg as a source image, first aligning the face and then generating the A4 projection. So let me run this code, and then the display image method is going to show the loaded image. So this is the input image, and it's validated through this align face. If you'd want to change the file location, you can actually remove this test input, and it is just designed from that. But if you would want to change, that's the place where you would change. So now we have our input image is generated, and here is our E4E projection style object. Now, depending on which pre-trained model you would want to use, so here a list of pre-trained models are available. So for example, if you would want to use the Disney model, and with this Disney model, if you would want to preserve the color or not, depending on your color preservation, a particular model will be downloaded from the Google Drive, and that's where this model will be downloaded, and these two values, the number of samples as well as the seed, will be set. So let me run this code. Here we are using the Disney pre-trained model with color preservation, and here you could see that the 133 meg Disney model is downloaded, Disney with the color preservation. So three models we have already downloaded earlier with the library, and here is our Disney preserve color model. Checkpoint is also downloaded. Now checkpoint generator, and as you could see here that we are loading the model here, and as you could see here that checkpoint model is currently is the whatever the design we have selected or style we have selected. So that particular model is being loaded here. Now we can use this code where it's using the torch.noGrid, and as you could see here that we are using the original generator to generate the results. So let me run this code. If you are choosing a particular style such as arcane multi or sketch multi, for example here arcane multi or sketch multi, it means that we need to provide the sketch file. That is what is being set here, and they are coming out from style image aligned. So you could see a style image aligned. So some of these styles are available here. So we are setting it up, and this time the style image is transformed, and style path, whatever style it is, has to be loaded here. Next step, we are displaying the image, and that's where we are passing the style and generation. So that is where the style, here is the source, and here is the output. So that's the style. This style is applied on this face, and this is the output. And as you could see, because of the capability inside the JoJo, the eye size and the eye character as well as the phase lines are added clearly in this output image. Here in this code, we are just taking the 5 random faces from the face dataset and applying the same style. If you would want to change the style and you would want to have the sketch, so for example, sketch multi, changing sketch, you will set this thing up. We will run this code again. That will download the sketch multi checkpoint model, which is about 133 meg. We can validate that that model is also downloaded in our models folder. So that's the sketch multi folder. Next, that model is loaded. So generator has that model. Now we are setting everything up, original generator based on the model. And finally, because we have used the sketch multi, so our style path is this sketch.png. If you will select any of other option besides these two, then the pretend.png will be applied. So there is a Disney, for Disney, there is a Disney.png. Next, creating the style image and then applying the transformation and generating the output. So source image, sketch, this is the style, and here is the output. If we want to apply the same sketch style to random 5 images, that's what we are going to see the results. So this is how you could use a pre-built model available and apply a particular style. In the next section, we are going to create our own style. It means we are going to train a model and then we are going to apply the style to the given image. So I already have these 4 images such as Doctor Strange, and these Doctor Strange 1, 2, 3, 4 images will be used as the style. So in order to generate the style, you need to upload those style file in this style image folder. So I have just uploaded these 4 files from my local machine to this style image folder. These 4 files I have listed here. It's listed here as a parameter. So let's set them up, and at this point we are going to generate the latent space. It means we are going to read these style file and we are going to process them and then generating the latent. So here you could see we are using E4 projection to generate the latent. Before that, we are making sure that face is available and face can be extracted. So let's run it, and for every file in our array is going to be used to generate the latent space. If you will only pass one file, then this code will run only one time, and the target means all the images. Latent means latent space means styles coming out from your source or style images. So target array and the latent array are going to be filled here, as you could see here. So latent and targets. Next, we are setting up these tags, and here you could see that we are showing the target images. So these are the 4 target images we are using in Doctor Strange 1, 2, 3 and 4. So here is our style reference. At next point, we are going to fine tune the StyleGAN. Our variables are alpha 0 to 1. Next, you want to preserve color. The number of iterations you would want 200 to 500. I will start with 200 first. If you would want to log the training results to weights and biases website, that's why you could use this. I'm not using it, so I will not check this, and it will update the log every 50 milliseconds. So we are not using it. So only these 2 options, and the alpha is set to 1. So here is alpha is set to 1. Preserve color is set to true. Iterations are 200. These 2 are not used, so this code is not going to be used. Here we are building the discriminator, and as you could see that we are using the StyleGAN. So both the discriminator and the generator, they both are using the base StyleGAN to FFFQ. Here we are setting the optimizer as Adam. So here is the fine tuning process. So let me run this code, and because we have selected 200 iterations, so this code will complete these 200 iterations, which will take few seconds to a minute depending on how many iterations you have choose. So our training is completed, and if we look into the style image, as you could see that these are the 4 images we have used as our style, and for our style the inversion codes are created for each of these style. That is what the JoJoGAN does little differently. Next, we can use the style now. So this is the style object. So we already have that style object. Everything is created at this point. So we will be using, here you could see that we are using the generator, okay, passing the original generator. It means we have already generator, as we have already used the generator and the discriminator. So let's run this. Here is style image align, and it's going to use the path reference image, and this is for how many samples we want to generate for the output image. That is here for the public face random faces, so that is only applicable to there. Next, we are generating the output based on Dr. Strange. Here the reference image, here is our output, here is the source image, here are the styles, and these styles are applied here. So here has been taken the eyes. If you look into here, the eye color has been pulled properly, so eye color has been changed. Some of the facial line as well as the goatee has also been brought clearly, and that is when we only use the 200 iterations. If you would have used the 500 or about 800 iterations, there will be a lot more clarity you are going to see in your output image. If we are going to apply the same style to these random 5 faces, this is what you are going to see results. So it just gives you a little more clarity about how the results going to be applied to various faces. If you would want to, for example, apply the another style such as animal, and here we are going to use the chimpanzee, for example. So let me hide this and use the names. So chimp is the animal which we are trying to use here. The chimp image I have uploaded from my local machine to this style image, so that will be available here as chimp. Now we are going to extract the styles from our style images. Here we only have one image, so this code will going to run only once, displaying the style image or images. So this is our style in the source style image. Now we are going to use the iteration count 500 so that we can get little more detailed style image. Code is exactly the same. So let's run this code. Counter has been started. So the 500 iterations are completed. Let's run the code again because we are already familiar with this code. Here we could see the reference image, and because we only have one reference image, so this is our reference image of chimp. Now we are going to see the output, and based on this image, this is the output we have. You could see that the eye size and the colors were adjusted, and there was some issue with this nose and the mouth, which is little different than human. So I think that's where the discrepancy is. So this is the result you have seen based on our chimp face. If we could apply the same style to these 5 random faces, this is the result. The code which we have covered in this video is available at this DeepWorks repo at prod_ramp account, visiting JoJoGAN face transfer, and here is the Jupyter notebook as well as the resources which could be very helpful for you to follow. So that's all we had to cover in this very first part of JoJoGAN style transfer AI model video. Please do check back for part 2 and part 3 of the same series video. Until then, thank you so much for your time, and I'm looking forward to seeing you in my next video.